Oh, good evening and welcome to this evening's webinar, Further Mathematics, Recursion and Finance, hosted by Texas Instruments Australia. My name's Rodney Anderson and I'll be your host for the webinar. This webinar is being recorded and we're available to view at a later date. You will also be able to download documents that the panellists also demonstrate during the evening. It's recommended that you view the webinar and not try the activities as you watch live, as you can pause, fast forward and rewind the recorded webinar at a later date. Now, if you have any questions or like to chat to during the evening, move your cursor up to the top of the screen. A menu drops down. Select the chat and send your questions to myself, the host. And then during the evening, I'll be checking the questions and chat through the evening, as I said, and I'll direct it to the panellists. You can also listen to the webinar via your computer, not just also using your phone. So you can also say, ring the direct toll-free number, and there's the meeting number. Follow directions on the phone, and you'll be listening via your phone. Now, don't forget to fill in the survey at the end of the webinar. Feedback's very important to Texas Instruments Australia and also to the panellists and I. And please take the time to do that so it improve the webinar series. And as usual, an email will be delivered in a day or two, and you'll have the links to your webinar certificate, which is great for your recorded of hours for the professional development through the year, and had links to the documents, as I said before. One of the panellists tonight is Sanjeev Messon, a very experienced mathematics teacher and physics teacher. You'll see them. Hello, Sanjeev.
Hi, Rodney.
And our first presenter for tonight is Brian Lennon. He's presented a few webinars this year so far. Hello, Brian.
G'day, Rod, and g'day, Sanjeev, and welcome to all participants.
Now, Brian, we're just talking about the finance tonight. We might have to talk to the media. There's been a big interest rate cut tonight, and the federal budget has been released, but there's been no mention of this webinar in the media. So do you think we should complain?
I think they're actually onto us, Rodney, because quite a few people have enrolled for this evening's webinar. And even though the media haven't published what we're doing, I think they're watching.
All right, so just waiting for
watching and learning.
Oh, very much so. I hope they learn from you. They will learn from you too. It's going to be a great webinar. See my face again.
Well, I'm hoping that by about now you're seeing my PowerPoint slide.
I certainly am. We certainly are.
Well, I'm going to launch right into it, mate. So welcome all, and I will firstly overview what I intend to look at in my part of this evening's webinar. And I think we need to start by a look at the study design, and I've quite cleverly hyperlinked that here, so let's look at that. Now, in the description of this evening's webinar, we talked a lot about first-order linear recurrence relations. Is that a relevant thing or not? Let's just start reading the study design. This is the new study design for this year, of course. The concept of a first-order linear recurrence relation, uses of first-order linear recurrence relations, the use of first-order linear recursion relations. I'm getting the idea that first-order linear recurrence relations is probably something we need to take a look at. Explicitly mentioned 6 times in the study design, and if you look at formulas such as this, you'll see that that also is a first-order linear recurrence relation. Oh, and what on earth is happening here? We've got this subscripted thing. What is this U with a little 0 below it? Equals A, comma, U with a N plus 1 equals B, U with a subscripted N. Wasn't this supposed to be the easier math subject? Our students, they're not the ones that are selected to do the highest level maths, and I don't know about you, but I've found that mine tend to freak out a little bit when they look at this subscripted business. So part of what I want to discuss this evening is what on earth does all that mean? So also, how is this, this is a very important point, how is this U subscript N or whatever, how is this different from what we previously talked about as the nth term? We'd previously been talking about T subscript N, you may recall, when, I know in my class at least, I talked about APs and GPs, the arithmetic and geometric progressions, and that was a big part not just of the Year 12 further mathematics course, but certainly of the Year 11 general mathematics course. I have a confession straight out here and now. The business and financial applications module is not one that I have actively invited when I've been teaching further mathematics. I have taught it. I've had some students that wanted to look at it because they do business studies and they thought that was very exciting, coloured pencil subject. Oh, did I say that? They thought, let's look at financial and business mathematics, but then it gets into all sorts of formulas. Formulas means algebra, and as I previously pointed out, our students for this probably aren't so excited about algebra, so it can be a challenging area. I have in the modules traditionally done matrices and networks, and then I've done number patterns. When I say I've done number patterns, I've allowed students to also select if they like the third module. We know this year, of course, all those rules are changed. There is no selection in that last module because number patterns and financial mathematics are now combined, and guess what? It's core. We have to do it. I like the number patterns. The financial side tends to lead into all sorts of formulas. Another thing we need to look at is what is this first order thing, first order recurrence relations. I will come back to it in a moment to address that. I wish to share with you one of my favourite things. Many of you, I expect, will already know this. Repeated operations on a calculator to illustrate patterns. If you recall, the third module that I taught was always number patterns. It's great. There's so much exciting stuff that can be done with that, and the calculator is fantastic at just showing the development of patterns. The same sort of thing can be done on a spreadsheet, and here's a lovely little gem that I'd like to share with you called the generate sequence command, which works in the spreadsheet for, guess what, generating sequences. And I also wish to share with you the Financial Solver, or a demonstration thereof. That's been around for a long time. It's a wonderful tool, and it's something that really helps students, but they need to learn to use it properly. Let's come back to this first order thing. I promised I would. In order to explain what a first order recurrence relation is, I'm actually going to show you something that I think you're hopefully more familiar with, which is a second order recurrence relation. Am I allowed to call that a difference equation? We did last year. I'm still calling it a difference equation, second order difference equation. And all our participants this evening will have heard of the Fibonacci sequence. The screen capture that you see there is from an activity that I downloaded called Fibonacci Fun. Of course it's fun because the Fibonacci sequence appears in all sorts of wonderful, naturally occurring instances. We know the Fibonacci sequence 1, 1, 2, 3, 5, 8, 13, etc. How does this develop? Every new term is the sum of the two previous terms. And here are a couple more screen captures from that activity. I pinched that from one of the Texas Instrument websites called Fibonacci Fun. You might like to take that activity too and use it. Do not use it with your further mathematics students. They are in Year 12. They are not allowed to have fun, okay? And apart from that, they don't have to do second order.
Well, you're the fun police tonight, are you, Brian?
That's right. No fun for Year 12. Rodney, I've got a daughter in Year 12 and it's no fun. So, and I keep reminding her of that. Get that smile off your face. So, yes, download this activity by all means. participants, but use it with cripes, I reckon a Year 7 or a Year 8 class would even work. So that's what a second order recurrence relation is, because each subsequent term or each term is defined in terms of the two previous terms. So quite simply, term number n, here's this subscripting thing, equals term number n minus 1 plus term number n minus 2, i.e. the two previous terms. So that's a second order recurrence relation. In a first order recurrence relation, you will not see this n minus 2 biso, you're only going to see n minus 1. But that's not going to work unless we know where did the whole thing start. I've seen various references for Fibonacci with f subscript 0, f subscript 1, etc., or f subscript 1, f subscript 2. Call it what you like. I've got here t0 equals 1 and t1 equals 1. And moving on from that, let me talk about repeated operations on a calculator to illustrate number patterns. Now, you will get a copy of this PowerPoint, which details screen captures of what I want to show, but let's really do it, like really do it on a calculator. If I put in a value such as 5, it's a nice number, and I press enter, the memory is now 5. If I commence the next command line with plus, you see I hit the plus key. What's plus? The previous answer. So I'm going plus 3. Now every subsequent time I press enter, it takes the previous memory and adds 3 to it. So you can see I've generated a number pattern by adding 3. Fairly straightforward sort of stuff. If I'd started with 5 and then multiplied by, shall we say, 2, then you can see what's happening here. Now, we may have previously called the first one of those an arithmetic progression and the second one a geometric progression. In our financial terms, arithmetic progression is like simple interest. We keep adding the same amount to our balance. A geometric progression is more like compound interest. And what I can do, you see on the last one here, is I can do a combination of both. I could multiply by 2 and add 3. So let's have a look at that on the calculator. Here's our 5. Let's go with multiply by 2 and add 3. And you can see what's happening here. What you're looking at now is what is called a first order linear recurrence equation. So it's first order because we're only using one term backwards in order to generate the next term. It's linear because, does this not remind you of something? What's happening is I'm taking the previous number, I'm multiplying it by constant. Let's call that previous number x. Let's call that constant, say, m. And I'm then adding another constant. Let's call that c. So I've got y equals mx plus c, or y equals ax plus b, depending what school you went to. So that's what it's all about. And this is what it looks like as recurrence relations. In the old money, it looked a little bit like this, and I quite liked these, but I would recommend at this point that you don't necessarily use them. I would go for what is in green. This is reflecting what's in the study design. This is what's going to be reflected in the exams. So talk to your students in this language here, the formulas in green, rather than here, the formulas that are in blue. Okay. The same sort of thing, as I indicated before, can be done on a spreadsheet. I love spreadsheeting. If you put an initial value, say 5, in the first cell, A1, and I'll make the next cell A1 plus 3. And if I then copy down or fill down that formula relatively, I will get that same number sequence, 5, 8, 11, 14, etc. The same sort of thing can be done for a geometric progression. And our hybrid first order linear recurrence relation, where subsequent cells are 2 times the previous cell plus 3 more for good luck. Now, I'd love to share with you now this little generate sequence command, because what I want to do is I actually want to count the term number. Look at this last one here, where I've got 5, 13, 29, 61, 125. I'm going to call 5 term number 0. Now, this is a very important point. Should I call it term 1 or term 0? Previously, teaching number patterns, there was often a problem with using these old blue formulas where Tn, T subscript n, the nth term meant the number in the number pattern, i.e. the first term, the second term, the third term. Now people, think about money, think about investments. If you place money into an investment account, say January 1st, 2016, you've put $1,000 in, you want to know what that's going to look like after 1 year, 2 years, 3 years, 4 years. Your bank balances will show initially $1,000, then $1,000 plus 1 year's interest, then $1,000 plus 2 years' interest, etc. The actual accumulation is a measure of iterations of interest. So the $1,000 is like the number 5 here. It's, I didn't mean to click that, the number 5 here, which is the initial value. There is no interest added. There's been no iterations. So in financial terms, we call this term number 0. T0 equals 5. And then Tn, n, the subscript n doesn't refer to the number that this value is in a pattern, but the number of times it's been changed, the number of iterations. I know the maths and methods teachers are listening to this too, because you've been looking at transition matrices. Yeah, that's been messed around too in the new curriculum. But with transition matrices, of course, we talk about the number of transitions. That's the important point. Get that one as a key one across to your students, please. So what I want to do is count the development of that sequence. Let's have a look at it. And also want to go back and talk about this linear thing. So the generate sequence command, what I want to do is put the numbers next to 5, 13, 29, etc. I want to put the numbers 0, 1, 2, 3, 4, because 13 is the number 5 after one iteration. 29 is the number 5 after 2 iterations, etc. Now, you know I could type in the numbers 0, then down and 1, 2, 3, etc. Or I could use the fill down command as we did before by using a spreadsheet formula. But let me show you this little baby. If you don't already know it, you're going to love it. If I've got in a spreadsheet, let's have a look. So what's happened here is I had the number 5, and then in the next formula I had what
spreadsheet at the moment, Brian. I'm not seeing a spreadsheet at the moment. Okay, still seeing a PowerPoint.
Got a delay. Okay, thanks, Rod. I'll slow down what I'm saying.
Well, this is delayed to me, possibly.
No, I can see the spreadsheet though.
Mm-hmm. Must be
it's a Queensland thing, Rodney. I reckon that's what's happening. Yep. Oh, look, at the risk of offending any other
there it is.
in Queensland, there's that time delay, is there not? I'm not talking about daylight savings.
All good.
Okay, in the In the first cell, I have 5. In the second cell, I have entered equals A1 plus 3. When I press enter, and people in Queensland will see this a little while later, that changes to 8. I'm going to grab that 8 and drag it down a few values. Let's go down, I'll go down to the 10th place, shall we? That's a hard one to find, yep. And so there's the, so there's our number pattern. And if I want to number them, put the numbers 1, 2, 3, etc. here, generate sequence. If I click into column B, which I hope most of us are now seeing, here's the clever little trick. It's also shown in the PowerPoint. But if I have my cursor in the second column, I press the menu key and I go to the data. You see the menus here. The first option there is generate sequence. And I click on that. Now, here's a fairly interesting thing. I need to type in a formula. You see U bracket N. What that's meaning is the nth term. So that's like U subscript N. And I'm now going to type, what should I put? U bracket N minus 1. And I close the brackets and I'm going to put plus 1. Now what on earth does that mean? Now a lot of students will look at this thinking, oh, I know about this brackety thing. You expand it. U n minus 1 means un minus u, does it not? So this will be un minus u plus 1. No, not right. What should be seen here is that this is subscripted. This means u subscript n, i.e. the nth term, equals u n minus 1, that is the previous term, plus 1 more for good luck. Okay? Now the initial term, let's make that 0, because remember I said I'd call term number 5 0, and I go a 0 here again, and let's go for 10 terms, because I want the number of terms here to match what I had in the previous column, and I'm stepping it by 1. Another way of doing that is setting the ceiling value. That is the highest number that I want to count to. Press OK, and that's happened. Let's just arrow down. You can see our numbers counting. Whoops, I've gone to 10 here. Look, let's just kill that. Sorry, because I can... I will redo that, in fact. Because what's happened is I started at 0 and I counted to 10, which made 11, did it not? Let's go data, generate sequence. You get the value of seeing this again, don't you? N minus 1 plus 1 for good value. Initial term 0 and term number 0, and we'll do, I shall go with 9 terms now for that. And there's the sequence of numbers. Let's have a look at it. So I've numbered these through. Got the idea? Why did I do this? Because I've thought, wouldn't it be nice to graph these? Let's call this, for example, this one here, the value. And let's call this the, shall we call it iteration? Okay. And let's get a graph of what's going on. So I'm going to put in a data and statistics page, and let's graph the iteration number from 0 through to 9, i.e. 10 terms, but 9 of them iterations from the original, and I'll graph the value. And now remember this, what's happened to the linear thing? Let's go. Woohoo. And PowerPointy thing. There you have it in your PowerPoint. But there's another interesting thing. If I do a linear recursion relation, for example, you can see here 5 has become 13 because what I did here is I doubled and added 3. 13 became 29 because I doubled that and added 3. 29 became 61 because I doubled and added 3. Let's try that same trick and see if we get that lovely linear thing. So I'm going to go back here. I'm going to change what's going on here. My recursion here was simply adding 3. I'm going to change it. I'm going to make that value A1 times 2 plus 3. And I'll fill that equation down. So you can see that I get a completely different set of numbers, 5, 13, 29, 61, as you saw before. And here they are counted. Let's look at the graph. Let's just redo that because she's going to be rescaled. I'm just going to completely redo that graph. So let's do the iteration number versus the value. Oh, dear, that's not linear. Wasn't this supposed to be linear recursion? Yes, it is. The linear recursion comes about not by comparing the value to the iteration, but by comparing the value to the previous value. So what I'm going to put in here, I'm going to start a thing called, I'm going to call it prevval, previous value, and I am going to put the earlier value. So I'm going to put, 5, 13, etc. down here. Oh, but hang on, what goes up here? What would have been, using this linear recursion relation, what would have been the value prior to 5, previous to 5? Well, I've got to go backwards through it. Remember, I'm doubling and adding 3. So backwards through that, if I subtract 3, i.e. 2, and then halve, it's going to look like 1. So I'm going to put 1 in there. And let's just put equals our previous value times 2 plus 3. I'm hoping my screen is kind of keeping up with what I'm saying.
Yep.
And let's grab that down. And it is fairly important. This is fun, trying to match the size of the drop down. And so now what I've got is in that third column the same as the first column, but it's just delayed by 1. In other words, the previous value. Let's get a picture of this. So I'm now going to graph the previous value versus the new value. And there's our linear. Nice. And let's just check that that's linear, because I can analyse it by doing a linear regression. And I don't know about you guys, I'm still part of the MX plus B school. I know the statisticians want the A plus BX. I can understand what they're doing. I can talk that language if I have to, but I'm still, give me the variable term first and then the independent. And guess what? It was 2x plus 3. I kind of thought it might have been. And Rodney, look, that's about all I've got to share. Except, can I quickly show one more thing? Because I just want to brag about something I wrote a couple of years ago, when my PowerPoint might catch up. The TVM Solver was one of the things that, perhaps it was on the old generation of calculators. It was on the TI-82s, 83s. I used it as a final feature in an activity that is on the Australian Curriculum Inspired website. that I called Growing Interest. In the Growing Interest story, there's a young girl by the name of Daisy who is a clever mathematics student. She wins a scholarship and she invests the money. She has a couple of options available, one of them being simple interest and one of them being compound interest, and she has to decide which is the better option. And here are some more screen captures from that activity. If participants haven't yet discovered the Australian Curriculum-Inspired website, I highly recommend they do, because there's a whole heap of great activities there. And they're free. There you get teacher notes, you get student worksheets, you get TI-Nspire files, the whole box and dice. Let me quickly show you what's going on here. Our friend Daisy invested $2,000, his PV, present value, and she invested it at 4% interest, and she did that over a period of 10 years, and she made no subsequent payments into that account during that time. In other words, it's set and forget, and we want to know how much money that's going to look like, and it turns out to be $2,960.49. I'll just quickly demonstrate how that works. On a calculator page, under Menu, Finance, TVM Solver, a whole heap of all sorts of wonderful, exciting things here too as well, by the way. What did we say? Number of time frames that this is going to compound for is 10. Now the percentage interest, I've forgotten what it was. Was it 4%, was it not? Yes. The present value is $2,000. That's what PV stands for. Making no subsequent payments along the way. If we look along here, payments per year is 1. That means how often the interest will be paid in, or other payments that Daisy might like to add to this account. And a compounding periods per year is 1. And the interest will not be paid until the end of a compounding period. So you have to have the money there before the bank will give you the interest. To make this thing work, you take your cursor to the value that you want to calculate, and then simply press enter. And here's our $2,960. The reason it's negative is because it's showing the direction of cash flow. So it's indicating that $2,000 was put one way, i.e. from Daisy to the bank, and $2,960 comes the other way, that is from the bank back to Daisy. The real excitement of this sort of thing is when you start playing with payments and looking at things like annuities and housing loans and the more. But I've passed my time, so Rodney, I'm going to hand it back to you and Sanjeev.
Thanks, Brian. Yep.
I really like playing with the TVM Solver for looking at interest rates of things under inflation. When we went to decimal currency in 1966, cost of posting a letter was 4 cents. It's now $1. What's been the average interest rate over that period?
Am I okay to take over, Rodney?
Go for it, Sanjeev.
All right. Hi, good evening, everybody. So,
we don't
Brian
yet see your screen.
Sorry?
We don't yet see your screen.
The screen, it says you're sharing your screen, so probably there's a lag. Still no?
I can't see yours.
I can see your screen.
There it is. I've got it now. Yep.
All right. Yeah. All right. Brian has covered the recursion aspect and bits of financial modeling. So I may actually skip straight to the CAS bit. Now, the good thing about the further maths course, although, there's this emphasis on using the recursion model, but knowing the exam, one exam is totally multiple choice and the other is short answer, where the students really are not expected to show, how they obtain the recursion pattern and so on. So they actually could use predefined rules. So the file that I've got over here, the next few pages will actually have a lot of predefined rules. And the students, if they have access to this file, it's got all the instructions there, on the notes page, and they can use it. So last year my students used this and they found it very handy. So I'll still go through the recursion bit as a starter. So we're going to generate a sequence here, and I'll just do what Brian did exactly. So I'm actually going there, and I'm going to create, I'll insert a calculator, and I'll insert my starting term as 11. And we're going to multiply this by 2 and probably take away 3 or subtract 3. So if I do that, multiply, so you'll see actually by the moment I click multiply, the word answer comes up on the screen. So it picks up the last answer. So times 2 and take away 3. And it generates the term. And if I keep clicking enter, it keeps generating the term. Now, if I am actually on the handheld screen, you will realize students may lose track of what is actually the term number. So that's term 1 there, term 2, and so on. But they have to scroll down, and they won't know what this 4099 is, which term number. So we can overcome this problem. If I go back again to my computer screen, probably I'll make that slightly more readable. Is that better? Okay, so let's, I'll insert another page just to do that, calculator page. And I'm actually going to insert a list this time. And you'll see I'm using the curly brackets or the braces. So now I've got the curly braces. I'm going to generate a list. So I'm going to actually type in 1. And let's say my starting term was 11. So the 1 in front is actually going to tell me the term number. And 11 is my starting term. So if I click that, now I've got 2 answers there by default. Now where my cursor is, that's going to tell me the term number, and that's the starting term for which I have to describe a rule. So now if you see, if I go, I use the word answer, and now I use the square bracket. Square bracket, and then if I type in 1, it will take up the first answer that I have, which is 1 over there. And then what I want to do is get the next term, which will be plus 1. And I do that. So that's going to generate term 2 and so on. And it will follow a recursive pattern. It will go 3, 4, 5, 6. And with 11, which is my second answer, so I type in 2. That's my second answer in the square bracket. Let's say I'm going to do plus 7. Let's just do that. Now if I click enter, it gives me my second term is 18. The third term is 25. Fourth term is 32, and so on. Am I going too fast, or is it okay?
It's synchronized well for me, and it looks good.
Oh, all right. Yeah, okay. So we can just continue doing that. So it actually tells you what term number you are finding. So we're still doing the recursion, and you can do it with as many lists. So I've got only 1, but I could actually add another one, and I have done that later in the document. So this is a way to keep track of which your what is your term number. So still doing the recursion pattern. Now, I tend to use the notes and the calculator application more than the list and spreadsheet. List and spreadsheet is great, but I tend to use the notes and the calculator application. Now I'll show you something here. I'm going to actually generate another list. So to generate a list over here, I always put the curly brackets or the braces and I type in my numbers, let's say. So I've got 8 terms or 8 items there in my list. And then if I go and do control store, I give this list a name and let's just call it M. So I'm going to store this list as M. Now I go and insert a list and spreadsheet page. And if I just type in M up there, you'll see actually it comes up in bold and it picks up the list that I created. Okay, now what's the benefit of this? At times people, the calculator screen is more readable than the list and spreadsheet page. So I tend to use the calculator page more often. So I'll go back to my page here where I created this list. And we are going to create a rule and we'll use the arithmetic sequence rule. So let's do that. And I called my list as M. And let's generate a rule. So I'm going to go, A is my first term. So let's use 11 as the first term in this case. Plus my list is this. So it's basically going my new term. So I'm specifying the rule. So it is still recursion. So that's the previous term. M minus 1 is your previous term. That's going to be your new term. And we are saying times, let's put any value, say -2. And see actually it generates the list. Now this is more readable. So what I've got on top is first term, second term, third term, fourth, and so on, 8th term. And here it gives all the terms. So we have still followed a recursion pattern. We have followed the rules. So that's the term we want, that's the original term, and we have specified the rule there. So that generates it as a matrix, and it's more readable. Now, if I did the same thing on a notes application, you will see it becomes, you can actually make live changes. So I'll copy this and insert a notes application. And I need to actually use a math box there. And it stores the list. And then if I go back here and I just copy this rule that I had.
That is very clever.
It generates that. But now if I go and change my list, I want to add more terms. If I go and do 9, 10, and if I just click enter, you see actually it makes a live update. I can't do this on the calculator page. I have to do it as a new calculation, but on a notes page, I can actually make all these variations. So all I need to do is change the number of terms there. So if I go back to 6, let's say, and I click enter, it just updates over there. And you could use this for arithmetic or geometric sequence or any other sequence. So this is using the calculator screen here. I can use the same thing on my list and spreadsheet page. So if you see, it's actually made the change here as well. So the notes page is controlling it. So if I go and type in 7, 8, 9, I'm back here. If I go to my, I should have put a comma there. So I'll go back and correct that. So So the list and spreadsheet page gets updated. I can go and paste the rule there. Now here it's going to ask me what reference am I doing in this case. And by default, it actually is set to column. I need to actually do a variable because M is my variable. So I select variable and then again variable invalid expression. I messed that up. So let's go back. I have to redo that again. Okay, and variable. Not sure why it's doing that. I know why.
Is it because of the number of terms?
Yeah, no, I need to get rid of that. Okay, so no, I think it's not the number of terms because it should pick up the value of M there. I need to get rid of that.
Two equal signs.
Yeah, and get rid of that. I'll just probably type it in there better. So that equals M times, I can't remember what was the expression. I'll just go times 2 minus 11.
Have got the M there. Yep.
Yeah, that should get, yeah, okay, that should be better. And variable reference, and that should hopefully, yeah, so that fixes
Cool.
that.
Yeah.
And if I did the same thing on the notes page, I wouldn't have had to go through column reference because it straight away actually picks it up as variable reference. And that is one reason I prefer using the calculator page. And over here, actually, if you have a good look, if I look at the formula bar, it actually puts prime, and it will do that because it's actually doing a variable reference here. So the list and spreadsheet page would do that. So you'll see it's 2.m with a prime. So that's a variable reference there. But the calculator or the notes page, you don't have to worry about that. It takes care of it automatically there. All right, so Brian has gone through the sequence generating template. I won't go over that, but you can actually use that on the calculator page. If I go back there or the notes page, so let's say I'm on the calculator page, you can actually access that using the catalog. And if you go under sequence, if you just type in S, you'll see a sequence generator. And if you put the wizard on, you'll actually see it tells you how to use it over here. So I won't go through that because Brian has already covered that aspect. But we can use it on the calculator screen as well.
It's quite interesting how integrated everything is, isn't it?
Yeah, it is. It's great, yeah. So everything is actually available on in the catalog menu. And the good thing is if you just turn the wizard on, it tells you exactly what you have to do. Okay, if I go back to the document that you will be getting, this is the document that you'll be getting. It's actually got all instructions written out over there. So if I go to any of the page, you'll see I've got instructions, what it does, and it's actually, that's the notes application. Underneath is the calculator, list spreadsheet, and how to generate multiple sequences using a calculator recursion. So all the instructions are there. So what you will notice, there are actually quite a few different ways in which you can do recursion on the calculator. That means obtaining the terms of a sequence, whether it's arithmetic or geometric or any series. So all the instructions are there. I've already been through this, so I'll skip that part because I think we just have about 10 minutes remaining and there's quite a bit to cover. So this uses I just thought, okay, let's do this bit. If you want actually the sum of a series, there's a few different arithmetic series or sum of a sequence. There are a few different ways in which we can do it. So this one, I've again used the calculator page, and I've used the recursion method. Exactly the same thing over here. So my first term is 5, and obviously the first time I do it, the sum would be 5. So I've got 1, 5, and 5. So 1 represents the first term there, and 5 is my starting term, and the sum of the terms is 5. And then I've used actually that if I copy this here, and I go back here, insert a new calculator page. So I've got that series there, or sorry, my list there. And then I want to do this. Answer 2, take away 2. So we are subtracting 2, and then in the third case, we are actually doing the sum. So let's go back here. So I'll go answer 1. Plus 1, comma, and then I'll go answer 2. And whatever rule I'm following, let's just do say 2 times that. And I don't know why my keyboard is playing up. And take away 5. So I've given it the rule, comma. And now I want actually the sum of this and the next term. So I'm going to go answer 3. Plus what I'm doing here. So that's what we are doing, and answer 3 plus 2, and that should be a plus. Yeah, that's fine. So if I go and do that, it generates. So now you can see it's actually giving you a running total. So 5, 15, and so on. So it's giving us a running total. So that's actually the sum of the sequence, which is series. You could do it on a list and spreadsheet page, or anyway. So let's go back here. We'll use this option over here. And I've already actually defined my terms over here. I've stored the value. If I go back in here, I've somewhere stored the value of A. So I've stored N, I've stored A is 5 and D is -2. So those values are stored. So if I go and use this template here, we have those templates. And this one here is the sum template, the summation template. So I'm going to specify the rule, which is A plus, the sum of a geometric sequence. So we'll just go, my first term is A, which I've stored. You can actually put the values there if you want. Let's do it with the values, doesn't matter. So we'll do 5 plus, my list is stored as M, oh, sorry, should be, yeah, M, and let's say I've got a value for D, but I'll change the value for D, and I could use any value here, say 11. Now I want to start with M from my first term, and I want the sum of the first 5 terms. So it's going from 1 to 5, and it should actually give me the total, that's 135. So it's using the summation rule. So my rule is starting term is 5, and the value of M goes from 1 to 5, and I'm multiplying that by 11. So you could actually use any starting value. If I did this, what may happen? So my starting value is 5, and that's 5 as well. It actually gives me the 5th term. So this is another way of obtaining the 5th term of the sequence. So it's, if I put this low value and that value is same, it's going to give me that particular term. I could have started from any other number. If I want to go for the sum of the 7th term to the 9th term, so I can go 7 to 9, use the rule, and it gives me the sum. So that's a good way to obtain the sum there. I could do this using another option here, and if I go back here into a list and spreadsheet page, I'll just use this. So I've actually generated a sequence. So my sequence is over here already. So the terms are 5, 3, so on. I'm going to repeat this over here. The calculator again has a built-in syntax, which we refer as the cumulative sum. So if I go under statistics and data. If I go under data and list method, you will see over there, where did it go? List operations, sorry. List operations, cumulative sum. If I click that, and I want the sum of these terms. So if I just go and type in whatever my list is, it will give you a running total. So actually it's doing that. So these are my terms, and this is giving us a running total, which is basically the series over there. So that, if I put my cursor there, that's the sum of the first 11 terms. That's the sum of the first 12 terms, and so on. I could do it for any list. Let's say if I just go back to this document, I save this as M. I could actually do the sum of this here. I can do it on this calculator screen as that's the notes application. If I'm using the notes application, I have to insert a math box. And now if I go back into calculations and add list operations, cumulative sum, if I do that, I could actually do the cumulative sum of M, which I don't need to, but it's actually giving me a running total. I should have done that one there. So if I copy this here, and see, that's the good thing about the notes page. You can actually make live changes and calculations, and it gives me a running total of all those terms there. Okay. So the file that you will get will actually have everything. So there are a few different ways. I've used the cumulative method. I've used the list and spreadsheet method. Now, I've barely got 2 minutes remaining. So I'll actually quickly go back here into this file. And you'll see I've got the second problem over here. Arithmetic sequence. I have defined all the rules. Now, students can, by all means, use these rules. It gives the instructions, that's finding the common difference. That's defined as the arithmetic sequence. And over here it says generate terms of an arithmetic sequence. And as an example, I've got my starting term is 7. The common difference is -2. And that 8 says it will generate the first 8 terms. So all they need to do is click on whatever the terms they want. If I change that to 11, it will generate the first 11 terms. So everything is generated there. All they need to do is to change those values. So if I change it to 4, it generates all those values. So I've done it. So that's for the first 11 terms. If you want a specific term, again, the rule is defined there. So that will generate the 8th term. I've got the same rule applied. It's going to generate the 5th, 6th, 8th, and 10th term if I do that. And let's change that value so you can actually see a live change happening. And let's change the common difference to -3. And it generates those. So the 5th term is -8. The 6th term is -11. So it has all the instructions. So you can change it to whatever you want. So if I quickly go through that, it's got the general formula. So it will give you the formula, the arithmetic sum, the first method, the second method, the instructions are there, generating a difference equation. All you have to do is to use the letter N and it will actually give you the rule. And then this goes on to geometric sequence. The rules are defined. So it's this, if you start using with the students in the class, you can teach them straight using this. But at the same time, you can install this on their computers. You can pass this file onto them and they can use it. And it's got the instructions and they can print it off and put this in their reference book. So actually they know what each of the defined rules is and they can use it for their exam. I had quite a bit to cover, but I think due to paucity of time, I'll stop there. So Rodney, over to you. But this file will be available to you all. And if you have any queries, feel free to get back to me. I think there should be information about me as a panelist, my email contact and so on. Or you can contact Rodney and he'll be getting in touch with me. But actually the file has got all the instructions there.
Yeah, thank you, Sanjeev.
Yeah.
Thank you very much for that.
There. Yeah.
Yes, there's so much there, isn't there? Like you've covered a lot and you had a lot more to cover as well. So
yeah.
As we said to all participants during tonight, the webinar is being recorded and can be found on the Texas Instruments Australia website. So if you've actually just type in education.ti.com, even if you don't know the website, just /Australia, you come to there. In the middle of the screen, you'll see that there is the webinar. So let's click into there. And you're looking for a recorded webinar. Let's see how my internet's going tonight, and you'll see what is upcoming, which was tonight with Brian and Sanjeev, and then tomorrow night we have Bojana and Pam with the functions and algebra, and there's many, many more for the rest of the term. But you're looking for the pre-recorded webinar, so click on the Demand tab, and you'll see, what do we have, the 20th of April, Brian and Peter Fox, and you can actually download the documents. You can play the webinar live or download it, and you see the tab to the right-hand side. There's many, many, many there, so lots to see. Now, during Brian's presentation, you'll see on the home page, or if I just go to the home page and make sure you've clicked into here, so you can actually go into the Australian Curriculum Inspired, and you're looking for Brian's example you mentioned before, so click into Year 10, and then let's have a look. We go the number and algebra. There we are, money and financial mathematics, and then growing interest. And if you click into there, you can download associated documents. So don't forget to complete the survey at the end of this webinar, and you'll get an email in a few days' time, or a day or two, and you'll have links to your certificates and links to all the information. And within, say, end of this week, early next week, the recorded webinar will be online, as well as documents that Sanjeev and Brian were showing. So thank you, Sanjeev.
Thanks. Yeah, catch you later.
Okay. Thank you, Brian.
Thanks, Rodney. Been a heap of fun. I've learned a heap of things too.
Very informative there. Lots to see, lots to actually investigate later on. So take care, and we look forward to your participation in future webinars. Bye for now.